This is the summary for Lesson 9, solving problems about proportional relationships. So if a relationship between two amounts or two quantities or two properties is proportional, what do you look for? So what I look for is, what are those two properties? And between those two properties, is there a ratio that connects the two properties? So for example, in this first problem right here, or first example, a bird is flying at a constant speed. There's a time and there's a distance. So what's the relationship between that distance and that time? Is how much distance there is, how much that bird flies per amount of time. So per minute, per hour. If there's a tub filling with water, there's a relationship between the volume that the tub is filled up and the time it takes to fill that volume. So the relationship between the volume and the time. So there's so much volume that's poured into that tub over a certain amount of time. So volume per minute, volume per hour. If an aardvark is eating termites, there's so much time it takes for that aardvark to eat those termites. And so that's the number of termites eaten per time or per minute or per hour. So the two properties are termites that are eaten and the amount of time, and the ratio of those two properties is what connects them. So if you're given an amount of time up here, you're going to calculate the distance that you fly. So the time is 1 hour 15 minutes. So the total distance flown is the ratio between them times that amount of time. That's going to give you the distance. Or if you're given, again, the amount of time, how much is that tub filled up in that amount of time? So in 7 minutes, how much is the tub filled up? So it's 7 minutes times the rate that tub fills per minute. Or if you're given an amount of time, again, for the aardvark eating termites, how many termites has been eaten in 15 minutes? So you know that relationship. It eats so many termites per minute times that 15 minutes is going to give you, you're going to calculate the number of termites that have been eaten. You can also look at the relationship, the reciprocal relationship, or going the other way. So if you're given the distance the bird has flown, you can then calculate how long did it take to fly that distance. So this is the opposite. Up here, you're given the amount of time the bird is flying. Down here, you're given the amount of distance the bird flew, and you're asked to calculate how long did it take to fly that distance. So you're given distance and you're calculating time. And I would practice setting up the reciprocal relationship or the reverse relationship for these other two, as I did for the bird flying up here. So what's the reciprocal relationship going to be? And just look at what I did here. So distance is equal to distance per time times the amount of time. So that distance per time, think about what that's saying. Distance per minute, distance per hour, and then you're given, say, 3 hours. Well, if you know the distance in 1 hour times 3 is going to give you the distance in 3 hours. But the reciprocal relationship is time is equal to time per distance times the distance that you're given. So in this case, it takes 5 minutes to travel a mile. And then you're given a distance of 3.5 miles. So you're going to multiply this ratio times 3.5. You know the distance for 1 mile, and you're given 3.5 miles. So how long did it take to travel that? Well, that's that ratio times 3.5 miles. So try to do the same for 2 and 3. Try to write the reciprocal relationship or the reverse equation going the other way. Now, how can you decide if a relationship is proportional or not? You look for a constant of proportionality. Now, this is a fancy way of saying that up here. You look at the quotients of the corresponding values and figure out if they're same. Basically, you take y, you divide it by x, and you see if that's a constant amount in every situation that you're given. That is figuring out what the value for k is, or the unit rate. So is there a single value that you can multiply by to get whatever y is in the equation? hard to talk about without specific examples. But that K is that constant of proportionality. So if there's a constant amount that you can multiply by, then the relationship is more than likely is proportional. And then you can set up the equation. So I would always go back, and if you replace K with y over x, then you get the same kind of equation that we've been writing. Y is equal to y over x times x. Without numbers in a situation, it's hard to understand. So that's why we ask you to think about it given a situation and multiple times. It's the same thing. You're doing the same thing every time. And here you're just writing a common way of looking at that relationship. So y is equal to y over x times x. And we just call that y over x, that relationship or that ratio, a special value called the constant of proportionality. And usually we calculate what that is as a unit rate. How much per minute, how much per distance, per mile, how much per package. So we usually, how much per dollar. So we usually calculate a unit rate.